our third lesson, still under the topic on functions. Now in this video, we will be dealing with the quadratic function. A quadratic function is a parabola, and the equation of a quadratic function may take any of the two forms: y is equal to a open bracket x plus p close bracket squared plus q, and we call this the turning point form of the equation of a quadratic function. And it may take the form y is equal to ax squared plus bx plus c, and we call this the standard form of the equation of a quadratic function. In this lesson, we will focus on the turning point form, and in the lesson that comes after this, we will deal with the standard form, okay? Now, the turning point form of the equation of a quadratic function is an equation of this form, where a determines whether the graph is concave up or concave down. Now, if a is a positive value, then the graph is concave up, and the turning point occurs on the minimum point of the graph or the lowest point on the graph, okay? And if a is negative, the graph is concave down, and the turning point occurs at the maximum point on the graph, okay, which is the highest point on the graph. Now P locates the axis of symmetry of the graph. Now to get the axis of symmetry, or the equation of the axis of symmetry, we equate x plus p to 0, and then solve for x. X is equal to a negative p after sending p to the right hand side of the equal sign. And the coordinates of the turning point of the graph are given by negative p and q, where negative p is the x coordinate and q is the y coordinate, okay? Now here is an example of a graph defined by the equation y is equal to x minus 3 squared minus 9, okay? Now what we want to do is to study this graph and analyze some of its properties. Now the given equation of this graph is an equation of this form: y is equal to a open bracket x plus p squared plus q, okay? Now in our given equation, a is equal to 1, which is a positive value. Therefore, the graph must be concave up, with the turning point of this graph occurring at the minimum point, okay? Now, the equation of the axis of symmetry can be obtained by equating x minus 3 to 0, okay? X minus 3 is equated to 0, and then solving for x. X is equal to a positive 3. Now this equation defines a line, a vertical line, which cuts the x-axis at 3, okay, which is this point. Now, an axis of symmetry is an imaginary line that divides a graph into two mirror images of each other. Now, if this line is our axis of symmetry of this graph, then this side, which is the right-hand side of the graph, must be a mirror image of this side, and this side must be a mirror image of this side. Now to plot this graph, as you can see how neat it looks, I used a software. What we are going to do next is to try to plot this graph by hand, okay? Let us do that right now. In this exercise, we are required to sketch the graph defined by f of x is equal to x minus 3 squared minus 9. Next, we are required to write down the domain and range of the graph, okay? Now, the first step, which is step 1, is to identify the curve from the given equation, okay? Now, our given equation is an equation of the form y is equal to f of x. Remember, f of x is just another way of saying y is a function of x. And this is equal to a x plus p squared plus q, okay? Now in our case, a is equal to 1, which is a positive value. Therefore, the graph must be concave up, with the turning point of the graph occurring at the minimum point of the graph. Okay. Now the next step is to determine the x and y intercepts of the graph. Okay. Now the x intercepts occur when f of x or when y is equal to 0. Okay. That is x minus 3 squared minus 9 is equal to 0. Now we can rewrite this equation as x minus 3 squared minus 3 squared. Now remember, a squared minus b squared can be factorized to be a plus b multiplied by a minus b. Okay. Now in our case, a is x minus 3 and b is 3. Now factorizing this, we get x minus 3 plus 3, okay, x minus 3 minus 3. This is 0, this is 0. Now negative 3 plus 3 gives us a 0, therefore this is x plus 0. And negative 3 and negative 3 gives us a negative 6, and this is x minus 6, and this is equal to 0. Now solving for x, we get that x is equal to 0 or x is equal to 6. Therefore the graph cuts the x-axis at 0 and 6. Okay. Now since the graph cuts the x-axis at 0, it must pass through the origin. Okay. Since x is equal to 0 is also y is equal to 0, so when the graph intercepts this point, it also intercepts the y-axis. Okay. So we can easily confirm this by determining the y-intercept. Okay. This occurs when x is equal to 0. So we let x is equal to 0 in our equation so that we can solve for y is equal to f of 0, which is equal to 0 minus 3 squared minus 9. Now 0 minus 3 is a negative 3, but when we square this negative 3, we get a positive 9. Okay, so we have 9 minus 9 giving us a 0. Okay, therefore the graph cuts the y-axis at 0, so the graph okay goes through the origin. Okay, to be something like this. Now the next step is to write the equation of the axis of symmetry. Okay, now to obtain the equation of the axis of symmetry, we equate this part of the equation to 0. Okay, that is x minus 3 is equal to 0, and then solving for x, that is sending negative 3 to the right hand side of the equal sign, we get x is equal to a positive 3, and this is the equation of the axis of symmetry of the graph of f. Now the next point is to write the coordinates of the turning point. The coordinates of the turning point are given by negative p and q. Okay, now in our case, p is negative 3. Okay, therefore negative of negative 3 must be a positive 3. Okay, and q is negative 9. Therefore the coordinates of the turning point are 3 and negative 9. Okay, now the last step, or the fifth step, sorry, is to sketch the graph and indicate all the intercepts with the axis. Okay, now this is the y-axis and this is the x-axis. Okay, now we know that the graph intercepts the x and y-axis at the origin. Okay, We also know that it cuts the x-axis at 6. So if we let this be our 6, and we know that the turning point occurs at 3 and -9. So if we let this be our -9, and if we go ahead and let this be our 3 on the x-axis, then the graph's turning point must be somewhere here, okay? And the coordinates of this point are 3 and -9, okay? Now the next step would be to join these points by freehand, okay? So we go ahead and join the right hand side of the graph, okay? We also join the left hand side of the graph by freehand. There you go. Now this is the graph of f of x is equal to x minus 3 squared minus 9, okay? Now the next step is to write down the domain and range of the graph, okay? Now as you can see, the x values of the graph stretch from -infinity to +infinity. That is all the real numbers. So we can write the domain as x is an element of real numbers, okay? Now the range, as you can see, the graph starts at -9 to +infinity, okay? The range must be y is greater or equal to -9, okay? Now that we have answered this question, we will now conclude this lesson with the past examination question, okay? Now let us go ahead and do that right now without wasting any time. This question is taken from February-March 2014, paper 1, and we are on question 7 in the question paper. Now the graph of f of x is equal to a, open brackets, x minus p, close bracket squared, plus q, where a, p, and q are constants is given below. Now points E, F, which is 1 and 0, and C are its intercepts with the coordinates x's. Now A, which is -4 and 5, is the reflection of C across the axis of symmetry of F. D is a point on the graph such that the straight line through A and D has an equation, g of x is equal to -2x minus 3, okay? Now the first part, which is 7.1, says write down the coordinates of C, okay? Now C, being a point on the y-axis, must have an x-coordinate of 0, okay? Now to find the y-coordinate of C, we take advantage of the fact that A is a mirror image of C across the line, which is the axis of symmetry of F, okay? Now if we go ahead and draw the mirror line, which is the axis of symmetry of F, okay? And recall that a line joining a point and its mirror image must be perpendicular to the mirror line. If this line is perpendicular to the axis of symmetry, therefore this line is a horizontal line, and therefore the y-coordinate of A is also the y-coordinate of C. Therefore the y-coordinate of C is 5. Okay. Now moving on to 7.2, it says write down the equation of the axis of symmetry of F, okay? Now since the axis of symmetry passes through the midpoint of A and C, therefore the x value, of the axis of symmetry must be equal to the x value or the x coordinate of the midpoint of C and A, okay? Therefore x must be equal to -4 plus 0. -4 is the x coordinate of A and 0 is the x coordinate of C, and this is all divided by 2, okay? Therefore -4 plus 0 is -4 divided by 2. This will be a -2, okay? We are now on the third part of the question, which is 7.3, okay? it says calculate the values of A, P, and Q. We will first determine the value of P since we have the equation of the axis of symmetry of the graph already, okay? Now we are given the equation of the graph as f of x is equal to a x minus p squared plus q, okay? Now to determine the equation of the axis of symmetry of a graph, given the equation of the graph in turning point form, we equate this part of the equation to 0. Now x minus p must be equal to 0, okay? Since we already have the x value, and that is equal to -2, we substitute -2, and it becomes -2 minus p is equal to 0. Now solving for p is equal to a -2, okay? Now that we have P, we can move on and determine the values of A and Q, okay? Now to determine the values of A and Q, we are going to use the 2 points A and F, okay? And substitute those points into this equation, okay? Now substituting the point A, y is 5, okay? And this is equal to A, x is -4, okay, minus, and p is -2. This is squared plus q, okay? Now we can simplify this further and say 5 is equal to -4 minus -2 is a -2, and if we square this we get a +4. This is 4a plus a q, okay? Next we substitute the point F. Here y is 0, okay? A, okay, and x is 1. This will be 1 minus a -2, and this is all squared plus q. Now 0 is equal to 1 minus -2, that will be a 3, squared, that will be 9, 9a plus a q, okay? Now we are going to call this our equation 1, and we'll call this our equation 2 so that we can solve simultaneously. Now to eliminate q, we are going to subtract equation 2 from equation 1, okay? That is 5 is equal to 4a plus q, and 0 is equal to 9a plus a q. Now q minus q is a 0 plus 4a minus 9a, that will be a -5a, and 5 minus 0 will be a +5. Now solving for a, we get that a is equal to a -1, okay? Now we have a, we are going to substitute a into equation 2 to solve for q, okay? Let me just create some space. Now substituting a into equation 2, 0 is equal to 9 multiplied by -1, which is a, plus a q. Now solving for q, we get that q is equal to a +9, okay? Now a is equal to a -1, p is equal to a -2, and q is equal to a +9. Okay. Now moving on to the fourth part of the question, which is 7.4. If f of x is -x squared minus 4x plus 5, calculate the x coordinate of d, okay? Now the point D is the point where the graph of f intercepts the graph of g, okay? Now in other words, this is a point where f of x is equal to g of x, okay? Now we are required to find the x coordinate of this point. Now since f of x is equal to g of x, that means we equate the equations of the two graphs, -x squared minus 4x plus 5 must be equal to negative 2x minus 3. Okay, now negative x squared minus 4x, taking negative 2x to the left hand side becomes a positive 2x, giving us a negative 2x. Okay, now 5 and negative 3, when you take negative 3 to the left hand side becomes a positive 3. That will be 5 plus 3, giving us a positive 8. Now this is all equal to 0. Okay, now to find the x value, we are going to use the quadratic formula. Okay, x must be equal to negative b plus or minus b squared minus 4ac. This is all under the square root, and it's over 2a. Now in our case, b is negative 2, so negative of negative 2 becomes a positive 2, plus or minus negative 2 squared, which is our b squared, minus 4. Okay, our a is negative 1 and our c is a positive 8. Okay, this is all over 2 multiplied by negative 1. Okay, now the next thing you are supposed to do is to plug in this into your calculator, and you'll find that x is either equal to negative 4 or x is equal to a positive 2. Now if you go back to the graph, you find that negative 4 belongs to a, therefore the x coordinate of d is positive 2. Therefore the x coordinate of d is equal to 2. Okay, now let us do the last part of the question, which says if the graph of f is reflected about the x-axis, write down the coordinates of the turning point of the new parabola. Okay, now the question is, what is the original turning point before reflection? Okay, now that is the point B. Okay, now the x coordinate we already know is the value of the axis of symmetry, and that is negative 2. Okay, and the y coordinate is q. We already determined q to be 9. Okay, so the original turning point is negative 2 and 9. Now to reflect a point about the x-axis, you follow the rule which says xy being the original point, the reflection should be x and negative y. Okay, so you have to multiply the y coordinate by negative 1. Okay, and our original, that is 7.5. Okay, and our original point is negative, let me just take a look. What is our original point? It's negative 2 and 9. Okay, it's negative 2 and 9. Okay, now to get the reflection of this point, okay, we take negative 2 as is, since it's the x coordinate, and multiply the y coordinate by negative 1, giving us a negative 9. Okay, therefore the new coordinates of the turning point of the graph after reflecting about the x-axis is negative 2 and negative 9. Okay, now this marks the end of this lesson. Thank you for watching. I hope you had fun. See you in the next video when we will be dealing with the standard form of the equation of a quadratic function.